Alright, I picked both of these because the same kind of trick happens in both of them. And it isn't so much that the material is so difficult, it's just kind of, again, using the special right triangle correctly. In this case, in the first case, you're given that the radius is 14. Now, why I bring this one up is that we normally like when the hypotenuse of a right isosceles has a root 2 on it. In this case, it doesn't, it's just 14. But you and I know that the relationship between the leg, the congruent leg, and the hypotenuse is a root 2 relationship. So either we're going to multiply by root 2 or divide by root 2. So to get that length, you're going to take 14 and divide it by root 2. And what you do to rationalize that denominator is you multiply by 1, or root 2 over root 2. And why we do that is because a nice thing happens when you multiply any square root by itself is it comes out to be a nice whole number. And then 14 divided by 2 is 7. And so we find out that the apothem is 7 root 2, or the half of the side is 7 root 2. The same thing is going to happen in this next experience. We take the 18 and divide it by 3 to get 6. Now 6 is each side, which means that the long side of our 30, 60, 90 is 3. I'm going to stand this upright so that we can see it. So that would make this the 30. This is our 60 down here, and the 3 is on the long side. If you kind of again look at the arrangement here and the arrangement here, we're in the same position. And this one does the exact same thing as the last one did, is that the relationship between long leg and short leg is to either multiply or divide by root 3. And in this case, we're going to divide by root 3. So once again, you're going to rationalize that denominator, and you get 3 root 3 over 3. Again, trying to emphasize, why do we rationalize? Well, this is exactly why. Root 3 times root 3 is just square root of 9, and the square root of 9 is 3. 3 divided by 3 is root 3. And so we get our apothem size to be the square root of 3. And you should be able to go from there to finding the overall area. Good luck.